Hello students, welcome to all my mentor math class. Today I have a great news for you. For that, you have to watch my full video. Students, hope you are practicing well, and I am surprising that you are watching my videos properly and consciously. And for your request, I have decided that I will going to discuss each and every topic one by one at first. After that, I will take the question answering session. And your job, you have to clear the concept properly at first, then you will solve the problem. If you have any doubts, just comments below and I will be there. I will give you reply each and every comment so that we can connect each other. And also I can guide you properly. Okay students, hope you understand. Now let's start the topic. Today I am going to discuss a new chapter, that is your limit. Okay, and that chapter already in your class 11, and those who are preparing NDA and JEE examination, and for that students this topic is very important also. Okay, so let's start the topic. So what do you mean by the limits actually? So actually limits, it comes from mainly basically it comes from calculus. Calculus is a vast chapter. Okay, calculus is your vast topic of a mathematics, and limits is a part of that calculus. Okay, so small part. Okay, so this limit is a small part. This is legal limit. So limit is your small part of calculus. Small part of calculus. This is the basic concept. So you have to clear the concept firstly. Okay. So limits, though, what you understand, that is limit is a small part of a calculus. Calculus is a very vast topic of your mathematics. Now roughly you can understand also. Roughly you can understand also this calculus. Look at this calculus. You can understand like that way. Calculus is a room. Let us take this is your calculus. Okay, this is your calculus. So calculus, let us take this is a room, and you have to enter that room, and that room is a locked. So that what be the requirement? What will be the require? That is, you need a key. So key, so that is, so you need a key. Open the door. Okay, so that key actually limit. So limit is a one kind of tool. Limit is a one kind of tool. Okay, this is your tool for open that calculus room. Okay, and after that whenever you enter that room, you see that there are lots of box be there, locked box, small box be there, and you can say that box is your functions. That box is your functions. Okay, so now you observe that each and every box are standing or sitting there proper way, and that box is your locked box. Again you have to use that tool limit. And why you use that limit tool? Because your requirement is you have to check the behavior of the each and every boxes. So you have to find the behavior of the function. In here, in your mathematics, you have to find the behavior of each function. And how you have to check the behavior of the function? So we have to use that limit tool. Okay, so limit tool you can use and find the behavior. So now you have to search what is your behavior, but how many ways we can find. So there are two types of behavior in mainly we have to check in your calculus, the small part. That is, you have to check first is behavior is Using limit, you can check either function is continuous, and or either the function is differentiable. And also you can check both. There are many functions, both differentiable as well as continuous. Okay. So mainly the behavior we have to check, that is either function is continuous or differentiable. So mainly we have to search of the function. Okay. So what you understand basically? So limit is a one kind of tool. So limit is a one kind of tool. This is your tool. We can use that on each functions. So why we have to use that tool? Because why we use? Because we have to find the behavior. So how many type of behavior? Mainly you can observe that is there are two main form. That is, one we have to check your continuous, another you have to check your differentiability. Okay, so you can see one function may be continuous, may be differentiable, or maybe both not, and maybe both also. So that is you have to check. So this is the basic concept, roughly that is your basic concept. Okay, so I hope you understand. That is, so whenever you go for study limit, first thing that limit is a small part of calculus, because calculus is a vast topic of your mathematics. So now roughly if you have to think that, okay, so you know that limit is a small part. Now you have to roughly what you think, that is calculus is one kind of room, and you have to enter that, you have to try to enter the room, so that you need a one key, because that room is locked. So whenever you open the room using by your tool, that is your limit tool, and after that whenever you enter that room, you can see now there are lots of box be there. In your mathematics there are a lot of function be there. Now your job, you have to check the behavior of each function, so that again you have to use your limit tool. Now how many behavior becomes, maybe mainly properly, there is two type of behavior we have to check. Either the function is continuous or differentiable. Maybe any one of the function is also differentiable, also continuous, also both, also neither not. Maybe it happens. Okay, so this is your roughly and basic concept. Okay, so note please. Now you have to understand by mathematical way that limit form. Okay, now roughly you understand that what is the basic meaning. Now comes to your limit. Actually limit is the study of neighbor point of real line. Study of neighbor point. Actually, so whatever study we have to do, basically we have to study regarding your neighbor point of real line. So let's take one number line. Okay, so let us take, this is your number line, this is your minus infinity, this is your plus infinity. Now this is, you can put here 0, you can put here 1, 2, 3, and like that, and here is your minus 1, minus 2, minus 3, and so on. Okay, now if I take let us take 0, let us take 0 point, we take 1 point is your 0 point. So now we have to check the neighbor point of 0. So how many ways or how many types of neighbor be there? That is, one is your the right hand side of neighbor of 0. Okay, so here you can see there one neighbor point, and you can see here also neighbor point, close point. Okay, close point. So you can see now there are two neighbor point. One is your from right side, one is your from left side for 0 point. Okay. So now, so this is your right neighbor. This is your right. This is your right neighbor. NBD, short form is your NBD. That is NBD also you can write, neighborhood point or neighbor point, NBD. That is your right neighbor point, and this is your left neighbor point, and this is also point. Okay, so and that right neighbor point we can represent like that way, 0 plus power 0 plus. That means this is the right neighbor of 0 point. Similarly, this left neighbor point we can represent by 0 minus. In that way we can represent like it. In similar way you can take this 3 point also. If I take 3 point, and after that we have to discuss about the neighbor of 3 points. So how many points, how many neighbor? Basically there are two neighbor points. One is your from right side close to 3, and from left side point close to 3 from left side. There are two neighbor points basically. So, and this point denoted by 3 plus, that is your right neighborhood or right neighbor of 3. This is right neighbor of 0. This is left neighbor of 0. And this also, that is your, you can represent 3 minus, and which is your left neighbor of 3. So this is the basic concept. So whenever mathematically when we can discuss about your limit, so you can understand that limit basically study of neighbor point of a real line. If you take any point from number line and you have to see that particular point, for that particular point, whose are the neighbor point or which are the neighbor point of that particular point. One is your from right side, is there one neighbor, another from your left side, then another neighbor. And how we can represent, that is, if I take 0 is a point, so this is right hand side neighbor is your 0 plus, and left hand side neighbor is your 0 minus. So this is the basic concept of the limit mathematical way. Copy please. Now comes to your geometrical observation regarding of limits. So what is the basic definition geometrically? What is the basic definition of limit? Okay, so look at this diagram. Look at this diagram. If I take like that one curve, let us take y is equal to fx curve. Okay, and you take one point. Let us take x equal to c point. Let us take x equal to c point here on your x-axis, and this is your y-axis, that is your f of x, and this curve is your y equal to fx. Okay, now first of all you have to work on that particular point on your x-axis, and whenever you go for discuss limit, and you know that limit means we have to study for your neighbor point on a particular point. So here the particular point is x equal to c, and we have to check which points are the neighbor point of c. Basically these two points are the neighbor points of the c, one from right side and another from your left side. And you know that for right side, how we can represent that point, neighbor point, that is your c plus, and for left side, that is your c minus. Actually this is your left neighbor point of x equal to c, and this is your right neighbor point of x is equal to c. So now if I see that particular point x equal to c, in that situation, what is the y value? What is the y value? You know, if x is c, so how we have to find y value? So this x equal to c, if you have substitute here, you got your f of c. So what is your y distance? That is f of c. And what is your x distance? That is your x equal to c. Now you can easily write that particular point. That is your, what is the coordinate of that particular point? X coordinate is your c and y coordinate is your f of c. Okay, so similarly you can find also for c plus as well as you can find also c minus. So if you comes to for c plus, you can easily find the y coordinate also. Okay, so let's take for c plus, if I, this is your y. Okay, so if I take this c plus, x is equal to c plus, then what about of y? What about of this coordinate? So basically this distance is your c plus, so x coordinate is c plus, and this is your y distance. If I substitute that value is here, so you get that is f of c plus. So that is your coordinate. That is your coordinate of that particular point, neighbor point of c, that is c plus. So what is the coordinate? That is c plus comma f of c plus. Similarly you can find the y coordinate for x equal to c minus. Okay, so you can find the y coordinate for c minus, that is the left neighborhood point of x equal to c. So similarly you can find that is y value. If I substitute x is c minus here, so you get the value y actually, that is your y distance. This is your y distance, y equal to c minus. So what is the coordinate? What is the coordinate? That is your c minus and f of c minus. That is your coordinate. So this coordinate is c plus comma f of c plus. This coordinate is c minus comma f of c minus, because if I substitute here x replaced by c minus, so you get your y value. Y is your c minus. That is your y means, that is you can write here f of c minus. Okay, and here is in that situation this distance you can write y equal to f of c plus, because x is your c plus, so y is equal to f of c plus. Put here x by c plus. Similarly here is your c minus, that is if you put here c minus, so you get y equal to f of c minus here. Okay, so now you observe that if I take x equal to c particular point, and if I using the limit concept, so we can easily find the neighbor point of c, which is your c plus and c minus, and that particular situation you can find also y coordinate, which is your, one is your f of c plus, another is your f of c minus. Okay, so now comes to your limiting existence. Okay, limiting existence, geometrical approach. This is your overall geometrical observation. Now definition of limit, of limit, that is if you see that limit exists for y equal to fx, this is a curve, this is your given curve. If I say that limit exists, that means if that is when you particular take point, when you can observe the particular point, if you see that for left limit, whenever you can observe for left neighborhood of c as well as right neighborhood of c, so that observation, if you see that their values, the limiting values both are same, that time you can say that limit exists. Basically what is the mathematical definition? Means geometrical observation. After that you can write the mathematical way. Limit exists if limit x tends to c minus fx is equal to limit x tends to c plus fx, which is, let us take different value, that is let us take else say. Okay, so this is main concept, and if you see that this relation satisfy, that means limit exists and the value of the limits, and you can write also these two form, these two form you can you can write like that way. X tends to C fx is equal to L. So this is your limiting value, that is your L value. Okay, so this is your mathematical approach. And what do you mean by lim, LIM? So actually this is lim means limit, and this x tends to C minus means that is left neighborhood point of x equal to C. You can write here limit exists at x equal to C point. Okay, and this portion, the left hand side, you can say that is left hand limit, that is you can shortly you can write LHL. Okay, and similarly this form you can write right hand limit, and you can write RHL. If you see that left limit is equal to right limit and this value gives some unique number, that is L. So this time the limit is exist at x equal to C, and the value of the limit, the limiting value is L. It is not meaning that is exact L value, that is approach to L, close to L. Okay, limiting value is L. So this is your geometrical concept, and you can read like that way. This arrow is suggest tends to C. Okay, tends to means approach to C minus. Here is approach to C plus. That means whenever you focus on particular point C, whenever you observe that C minus means we have to come from left side towards C, that is left neighbor point of C. And similarly C plus means that is it comes from right hand side, right neighbor of C, and this arrow suggests tends to. So this is the basic mathematical and geometrical observation of limit. Please note. Next comes to your, that is algebraic observation of limits. So what do you mean by algebraic observation of limits? Students, concentrate my lecture because of that is very important topic, and whenever you go for calculus, so this portion, this limits, this continuity, differentiation, they are the very useful from later on also. Okay, so look at this, the point. So algebraic observation of limits. So actually there are 7 quantities be there originally, that is you can write like that way. One is your 0 by 0 quantity, another is your infinity by infinity quantity, another is your infinity minus infinity quantity, another you can write infinity to the power 0 quantity, another you can write 0 to the power 0 quantity, another you can write 1 to the power infinity quantity also. Okay, and also you can write that 0 into infinity quantity. So there are 7, 1, 2, 3, 4, 5, 6, 7 important quantities be there. Quantities, 7 important quantities. So whenever you go for study algebraic observation of limits, so basically you have to learn, you have to know that what is the behavior of these 7 quantities. Okay, so one is your 0 by 0 form, and this infinity by infinity form, this infinity minus infinity form, infinity to the power 0 form, 0 to the power 0 form, 1 to the power infinity form, 0 into infinity form. These 7 quantities are very important because these quantities are very crucial, they are very clever. Because different situation, different answer be given. Okay, they are approaching, and there are different time, many times they are not given as a single way. Whenever you study for this topic, if you see one question, the answer is given, another question, the same quantity gives another answer also. So that's why this is a very clever quantity, because different way they gives the different answer. Okay, this is not fixed way, right direction you can't find. Okay, and basically these quantities, these 0 and 1 infinity, all these things, this is not a exact value. This is all values are limiting value, approaching, not exact value, not exact 0, not exact 1. This is all are the limiting value. Okay, so now student, you have a doubt because of, so you can, maybe you cannot understand what that told. Okay, basically you have to remember these 7 quantities, and you have to remember that these 7 quantities are very clever. Different time they are change their behavior different. Okay, and these exact values, this 0, 1, all are the not exact value, they are the limiting value, that is your approaching value. Okay, so now let's take one example. Let us take, like, if I take example like that way, limit x tends to infinity. Let us take 3x by, that is your 4x. Okay, and let us take another example, limit x tends to infinity. Let us take 5x by 6x, and another you can see, you can take that form, that is 2x by 6, that is 7x. Let us take 7x. Okay, so now you can see, if I put x tends to x is infinity, that is it suggests 3 into infinity, that is infinity form, infinity. Okay, that is your infinity by, if I put again here is x, that is also gives infinity. So this quantity gives infinity by infinity. Also, if I suggest, if you substitute here x by infinity, also this quantity gives infinity by infinity. And here also, if I put infinity x, that is you got the infinity by infinity form. Now all form are same, but whenever the quantity, whenever the situation, this first situation is 3x by 4x, and if you cancel this x, the actual value is, this gives 3 by 4. If you see that, if you cancel this xx, it gives 5 by 6. If you cancel again xx, it gives 2 by 7. So look at this, this infinity by infinity, it gives, there are many values. So in that situation, infinity by infinity 3 by 4. In that situation, it gives 5 by 6. In that situation, that gives, that is your 2 by 9. So I told you this is a very clever, and that quantity they are the changing their behavior different situation. Okay, so this is the main concept whenever comes to your limiting value, this infinity by infinity form, 0 by 0 form, they give different answer also. So that's why these 7 quantities are very important. Okay, and one thing I can write here, these 7 quantities actually undeterminate form, you can say, or you can say indeterminate form. Okay, so this is also you have to know. So these 7 quantities actually undeterminate form, or you can say indeterminate form. Okay, now you can take one example. Okay, so let one example, let one function y equal to fx is equal to, let us take x square minus 1 by x minus 1. Okay, so you can take this function, that is y equal to fx is equal to x square minus 1 by x minus 1. So you can see that function, if I put, you can see the function is defined for x not equal to 1. If I put x equal to 1, so denominator becomes 0, and if your denominator becomes 0 means this function is undefined. So that means, that is, if I put x equal to 1, for x equal to 1, it gives 0 square, that is 1 square, 1 minus 1 0, and 1 minus 1 0 by 0 form. If I put here, because we have to, here if I put here is 1 means we have to observe that particular point on number line, x equal to 1. You can draw like that way, plus infinity, because if I put here 1, so you can see that that denominator becomes 0, that means the function is not defined. Okay, so that's why this form is your undeterminate form, because of it gives 0 by 0 form, that is undeterminate or indeterminate form. Indeterminate form of limit. Now we have to calculate. Now we have to check. You have to see the condition. So that form gives another situation. That form gives another values. How it comes? Look at this. So you know that a square minus b square formula. If I put like that way, x square minus 1 square by x minus 1. So you can write a plus b into a minus b and divide by x minus 1. That is cancelled. So you got the value x plus 1. If I take limit x tends to that point, particular point is 1, x tends to 1, x plus 1. So when x approach to 1, the function gives, if I put here 1, so 1 plus 1 is equal to 2. So that means the function approach to 2. That means this 0 by 0 form gives the value 2. Okay. So this is the basic form. Also we can see like that way, you can draw like that way. If I box here, and let us take, this is for left neighborhood, left hand limit, left neighborhood. If I work on left neighborhood of 1, that particular point, after that we have to work on the right neighborhood of 1. Okay, so let's see how it comes to. Okay, so look at this. That is this is your x equal to 1. So we have to comes from left side to close to 1. So this is your neighbor point. If I take x is equal to that closed value of 1 from left side, we have to observe on this x negative. Okay, x equal to 1, that means 1 negative. You have to work on 1 negative, left hand limit, left hand side. You have to work on, you comes from left hand side close to 1. That is your left neighborhood point. Okay, you can write like that way, 1 negative. Okay, so if I take close to 1 point from left hand side, if I take 0.9, so that time value of fx, y equal to fx, you can put here. You can check also. That is 0.9 square minus 1 by 0.9 minus 1. So that means if I put here a square minus b square formula, so 0 minus that is minus 1, and 0 minus, this is plus 1 minus 1 whole divided by 0.9 minus 1. So this kind quantity cancel and you got the value 1.9. So you see that if x approach to 1 from left side, and if you take 0.9, the function approach to 1.9. Function approach to close to 2, actually this value gives 1.9. Look at this. If I put x is equal to 0.999, or again you can take more values close to 1 from left side. Similarly, you can find y equal to fx is equal to 1.999. So look at these values. Actually, these values approach to close to 2 from left side. Because this 1.999, 1.9 are all numbers belonging to left hand side of 2. Okay, so you see that, so left hand side approaches to 2 for particular point 1. So similarly you can check also right hand limit, that is your 1 plus. Okay, that is your, you can check right hand limit. It comes from right hand side to close to 1, that is right neighborhood of 1 plus also you have to check. Note please. Now for right hand limit, that is your 1 plus, you can check. If I take x equal to close to 1 from right side, if I take 1.01, you can see, observe the value of the function, what it gives, which value it gives. Okay, so put here again x replaced by 1.01 square minus 1 means 1 square by 1.01 minus 1. Again you can calculate this 1 minus 1 point, this is your 1.01 plus 1 into 1.01 minus 1 whole divided by, that is 1.01 minus 1, and this is cancelled. You got the 2.01 value. That is your 0.01 value you can see for that is x equal to 0.1 value. Similarly, if I put or if I take close to 1 from right side again, x equal to 1.00001, so that time also y function approaches to close to 2.0001. This is also, so this is also y approaches to, that is tends to 2, because, and these all values belongings to right side of that is 2 particularly. Okay, so if you see that, so you can write like that way. If x tends to 1 negative, then y equal to fx tends to 2 negative. Also, if x tends to 1 plus, then y equal to fx tends to 2 plus. So this is very important. In that situation, you can write left hand limit is equal to right hand limit, which is equal to 2, and in that particular situation limit exists, and the value of the limit is equal to 2. Very nice question. Okay, so in that way you can understand the limit form, and then that particular example you can understand. Okay, so note please. Now overall view, you understand that limits is a study of neighbor point of a particular point on number line, and you study also the what is the geometrical observation, you study also what is the algebraic expression, how we can compress or how we can explain with respect to any example, any function. Okay, so basically key point you can note please, that whatever you study now till now, key points very important, note please. Key point, first of all you study that is limit basically study of neighbor point of particular point of a particular point on number line or on real line. Okay, and number 2 also, this is your basically study roughly approach, also you can write like that way. Limit is a tool which is applied apply on the function. Why you apply? Because we need find behavior of the function. What kind of behavior we have to check? That is your continuity and differentiability. Okay, differentiability. And number 3, what is the geometrical definition? So let y is equal to fx be a function, then limit exists, if limit x tends to, let us take exit at x equal to c particular point. So you can write c negative fx is equal to right hand limit x tends to c positive fx is equal to, say, let us take L, some limit L. So this is limit exists, and this way you can write that way, that is this 2 gives limit x tends to c fx is equal to L. Okay, this is your 3 key points you can note please. Number 4, that is left hand limit, you can write like that way, x tends to c negative fx, that is called left hand limit. Also right hand limit you can write like that way, lim means limit x tends to x approaches to c plus fx, that is your right hand limit. If both are equal, if both are equal, that suggests limit. Those if these 2 values are equal, that 2 form comes together, that is x tends to c fx. that is exist. Okay, and your diagram, if you follow the diagram, look at it, that is very important. If I put here x is equal to c, and we have to check the neighborhood points here, that is your c plus, here is your c minus. So whenever it comes to your left hand limit, it comes from left side close to c, that particular point. Okay, obviously remember, so that side obviously x less than c. Whatever value you have to take from left side, left neighborhood of c, all values are x less than c. And similarly when it comes to your right hand side close to c, that is your c plus, obviously that region, whatever value you have to take from right hand side, that value is greater than c, obviously, whatever value you have to take. So this is the main concept you can remember, is minus infinity, this is your plus infinity. Okay, so note please this number 4. Next, number 5 is your algebraic form, that is your indeterminate form. So there are 7 forms you understand, that is 0 by 0, infinity by infinity, 0 into infinity, infinity power 0, 0 to the power 0, 1 to the power infinity. There are such of expression also, infinity minus infinity. These 7 indeterminate form, that is a very important form. You can note this also. Okay, so that is the main concept. This is the main concept regarding your limits. This is your introduction class. Hope you students understand what I already told. If any doubt, you can write on your comment box also. And next class I will start the algebra form of limits, and there are lot of important key formulas be there, and we are going to solve or exercise. Okay, so for the today, that's all. Thank you so much. Next class again I will come. Thank you.